Hi everyone, welcome back to GridPro. In today's video, we'll see how to mesh expansion bellows for fluid-solid interaction. Expansion bellows or expansion joints are flexible components used in piping systems to absorb movements and vibrations. They help compensate for thermal expansion, contraction, and other mechanical shifts in pipelines, ducts, and vessels. Here we have a geometry for the expansion bellows, which consists of three convolutions or bellows. Meshing for fluid-solid interaction for such geometries can be done easily in GridPro to capture the fluid flow behavior along with the structural loads. Let's start with the basic topology generation for the existing surfaces. We will refine the topology as we go ahead. Since this is an axis-symmetric geometry, we can create the topology for a 2D section and revolve it to form the full 360-degree domain. First, align the workplane to the center and turn on the cut plane for better visualization. We will create a basic quad structure and add inserts to capture the bellows. Now move the corners closer to the fillets to represent the geometry better. Next, a boundary wrap is performed to copy the top layer of corners for the solid region. It is recommended to do the surface assignments on the 2D topology before rotating it to 360 degrees. This reduces manual effort by automatically carrying the surface assignments throughout the complete topology. We will use the revolve option from Edit Topology tools to rotate the 2D section. Choose circular with core, which automatically creates a core at the center of the revolve topology. Revolve the corners about the origin along the x-axis. You can set how many times the selected sheet should be revolved. For this example, we'll use the default value of 16. We will use the corner group C1 to define the core. Corners in C1 act as peripheral points for building the central blocking. Make sure to turn on Update Corner Groups. This automatically includes all revolved corners into the same group, saving manual effort. After hitting Copy, the complete topology is created. Validity check shows the topology is valid with 896 blocks. We will take one cross-sectional sheet using Get Adjacent Sheet button for better visualization. Turning on the preview mode gives a better idea of the regions where density needs to be balanced. Balance the density, and let's run the grid smoother to check the resulting mesh. After loading the mesh, we see a grid with 0 folds and a max skew of 0.66. The grid may look converged, but if we take the cross-sectional slice, it reveals that the fillet regions can be captured better with more refinement of cells. This can be improved by applying compact enrichment to the corners around which the grid appears sparse. Group the existing corner sheet into a new corner group, keeping only the sheet that contains the corners to be enriched. Then use the Retain Selected Corners button. While holding the A key, click on the edge near the corner that needs enrichment. Repeat this process for the other sheets as well. Group all the corners for enrichment into a single corner group. Do a compact enrichment on these corners with the offset length of 0.6. The enrichment creates a structure similar to the internal wrap. The topology is valid with an increased number of blocks count from 896 to 1184, but the positioning of the corners is not proper. We can use the edge length to reposition the corners at desired locations for rapid grid convergence. Also, move the corners closer to each other on the top of the fillet surfaces to minimize gaps and improve grid density in that region. Additional inserts can be added to the domain, as the GridPro Grid Smoother performs better with a higher number of blocks having lower densities, rather than fewer blocks with higher densities. Let's balance the densities for this modified structure and run the grid smoother. As observed, the grid fillet regions of the bellows are now captured with greater precision. The quality check shows the grid has the max skew of 0.66. Additionally, we can align the topology to the grid, except for the sheets representing the solid surfaces at the top. After rerunning the grid, we can see that the sparseness on the fillet crest region gets reduced further. We hope this video helped you understand one of the approach to generating the fluid-solid interaction mesh for the expansion bellows. If you have questions, feel free to contact support at gridpro.com. Thanks for watching.